Hello everyone. In this video, we are going to discuss how to determine the nth term of a geometric sequence. A geometric sequence is a sequence of non-zero numbers where each term after the first term is found by multiplying the previous one by a fixed non-zero number called the common ratio. For example, if we have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5 as the first 5 terms of our geometric sequence, that means a sub 1 times r equals a sub 2, a sub 2 times r equals a sub 3, a sub 3 times r equals a sub 4, and a sub 4 times r equals a sub 5. Now, let's discuss how to find the nth term of a given geometric sequence. Example number 1. Find the fourth term of a geometric sequence given that a sub 1 is 2 and r equals 4. We are going to start with a sub 1, which is 2. Then to obtain the second term, we are going to multiply 2 by the common ratio r, so that's 8. Again, multiply by 4, that's 32. And then multiply by 4, that's 128. So the answer here is 128. Let's do another example. Find the fourth term of a geometric sequence given that a sub 1 is 1 and r equals 6. So here again, we start with a sub 1, which is 1. Then, to find the next term, we multiply it by the common ratio, which is 6. So 1 times 6 is 6. Then to find the next term, multiply by 6 again. So that is 6 times 6 equals 36. And to find the next term, we multiply by 6 again. So that's 36 times 6 equals 216. So this is our fourth term. Now how about if we are asked to find the 20th term or even the 100th term? So that means we will be multiplying so many times. That's a tedious task to do. So we really need a formula, and we are going to explain the formula. Suppose 1 is our a sub 1 and 6 our a sub 2, then 36 our a sub 3, 216 our a sub 4. So how do we find a sub n, or the nth term? So notice here that we always start with first term a sub 1, and we are going to use the first term in all of our terms here. So we have the first one, the first term is multiply by the common ratio to the power of 0, and the second term equals the first term times the common ratio to the power of 1, and then the third term, the first term times the common ratio to the power of 2, and the fourth term is the first term times the common ratio to the power of 3. So we have seen a pattern here. For a sub 4, the exponent is 3. For a sub 3, the exponent is 2. For a sub 2, the exponent is 1. And for a sub 1, the exponent is 0. So this means for a sub n, the exponent is n minus 1. So our formula is to find the nth term, or a sub n, we start with the first term and then multiply by the common ratio r, and then the exponent should be n minus 1. So this is the formula in finding the nth term of a geometric sequence. Example number 3. Find the seventh term of a geometric sequence where a sub 1 equals 4 and r equals 2. This time we are going to use the formula a sub n equals a sub 1 times r to the power of n minus 1. So our n here is 7, our a sub 1 is 4, and our r is 2. So this means a sub 7 equals 4 times 2 to the power of 7 minus 1. And simplifying, we have a sub 7 equals 4 times 64. So 2 to the power of 7 minus 1 is 2 to the power of 6, and 2 to the power of 6 is 64. Now, 4 times 64 is 256. So this is our seventh term. Example number 4. Find the first term of a geometric sequence whose fifth term and common ratio are 144 and 2 respectively. So we will use our formula a sub n equals a sub 1 times r to the power of n minus 1. So this time we will find a sub 1, and 144 here is our a sub n. Our n is 5 and our r is 2. So this means we have 144 equals a sub 1 times 2 to the power of 5 minus 1. So simplifying this part here, it becomes 16. So 2 to the power of 5 minus 1 is 2 to the power of 4, and 2 to the power of 4 is 16. Now since we are going to find a sub 1, we divide both sides by 16. A sub 1 is 9. Now your turn. Find the indicated term. Number 1, a sub 1 equals 3, r equals 2, find a sub 6. Number 2, a sub 1 equals 8, r equals 3, find a sub 5. Number 3, a sub 1 equals 81, r equals 1/3, find a sub 5. Number 4, a sub 6 equals 486, r equals 3, find a sub 1. And number 5, a challenge question, a sub 1 equals 6, a sub 3 equals 150, find a sub 4. You can pause the video and work on these 5 items. For item number 1, the answer is 96, and these are the details of our solution. Number 2, the answer is 648. We have here the details of our solution. Number 3, the answer is 1. We have here the details of our solution. Number 4, the answer is 2, and we have here the details of our solution. And for item number 5, the challenge question, I will discuss it with you. This is our formula, a sub n equals a sub 1 times r to the power of n minus 1. So we are going to find the common ratio first, using a sub 1 and a sub 3. A sub n is 150 equals a sub 1, which is 6, and r to the power of 3 minus 1. So because there are only 3 terms, a sub 1, a sub 2, and a sub 3. Now simplifying, we have 150 equals 6 times r to the power of 2. So 3 minus 1 is 2. Now dividing both sides by 6, we have 25 equals r squared. Now to find r, we get the square root of both sides, so r equals the positive and negative 5. Using positive 5 as our common ratio, the terms are 6, then times 5, 30, times 5, 150, and times 5, 750. And using the common ratio negative 5, we have 6 times negative 5 equals negative 30, times negative 5 equals 150 times negative 5 equals negative 750. Did you get all the items right? I hope you did. Thanks for watching, guys. This is teacher Rejil. Keep safe.